Hi everyone, my name is Upal Mahbub and I serve as the chair of the IEEE Computer Society chapter of San Diego section. I'd like to welcome you all to the first event of our 2025 invited seminar series. We have two back-to-back talks today on the domain of cloud computing. So today's virtual event is co-hosted by the Computer Society chapters of Santa Clara Valley, San Antonio, Pikes Peak, Oregon, Foothill, Boise, Dallas, Northern New Mexico, Orange County, San Fernando Valley, and Hawaii sections, along with the Consumer Technology Society, Communication Society, Signal Processing Society, and Vehicular Technology Society chapters of San Diego and IEEE Young Professionals Affinity Group of San Diego. As always, we have Open Research Institute Incorporation as our media partner for this entire series. I'll briefly introduce our two speakers. Our first speaker, Saidaya Yechuri, is a software engineer and security specialist working with the AWS Identity and Access Management team at Amazon Web Services. Prior to AWS, he spent almost 10 years at Dish Network and Spectrum, creating software for video streaming and media and enhancing user experiences with innovative features in the entertainment sector. Saidaya will talk about application security using identity and access management on the cloud. Our second speaker, Kunal Sekhri, is a software engineer with over 9 years of experience in building high-performance, scalable, distributed systems. He has led teams and collaborated across various departments to deliver exceptional software products. Currently, he leads a team at Google Cloud focused on improving the discovery of Google Cloud products and services, enhancing customer journeys, and making AI adoption seamless for enterprises, developers, and students. Kunal will talk about the best practices to accelerate machine learning on cloud platforms. So without further ado, I'd like to welcome our first speaker, Saidaya, to start his presentation.
Hello, everyone. Let me share my screen first. Hope you guys can see it. Yeah, hi. My name is Saidaya Churi. I'm a software engineer at AWS, working in IAM, Identity Access Management Organization. So I'm going to take next 20-25 minutes to talk about why application security matters and how IAM can be useful to secure our applications, and what are the major things involved in IAM while securing our applications. There are many features that IAM at our disposal, but I'm going to talk about a couple today within the timelines I have. And then if time permits, I'm going to do a very simple demo on how actually IAM works and how it looks. So let's get started. So to start with, why application security matters, right? So the first thing is evolving threat landscape. So these are the few threats that we have recognized and most popular, but there are several more as well. So the main ones are SQL injections. So if you are not careful about allowing SQL queries and parameters outside of the application, people can inject a query which is not intended and get the data that they wanted, which they should not be. And then cross-site scripting, right? So they send you a link. This is most popular one, and then you click it and things happen. You should not be clicking those actually. And then API exploit. So there are a ton of unsecured APIs out there where you can actually, with a simple parameter, you can get into the APIs and you can do whatever you want the system to do. So these are the popular ones, but there are several others getting pulled out every day. So this is one of the main reasons we want applications to be secured. And then the next item is data protection. So every consumer company saves customer data and customer information, sensitive information like medical records, financial records, whatnot. So data protection is very, very important. And if we do not protect the data of the consumer, there can be a lot of financial losses and other things. So just to an example, like uh, uh, the social security data that we lost in 2013, right? 147 million users' data was lost and actually compromised. So that's one example. That's how big it can be if we are not careful about data that we are storing in transit or rest. And then the next point that we need to make sure is we need to comply to some regulations, like general data protection or health insurance, or card protection, or California Protection Act. So these are the guidelines that every consumer company or any company that is actually working with a third party customer need to follow, right? And then financial impact. So any data breach or any impact in security wise can cost time and money both. On average, in 2024, each security impact cost $4.3 million to company. So here the company size doesn't matter. So on an average, it costed 4.3 million for each security breach, which is very, very huge. And then the next reason why we want to secure applications is the complexity is increasing day by day. As we involve more and more components into applications, there is more chance for threat actors to get into those loopholes. Because if the application is simple, it's reasonably simple to protect it. But if the architecture gets complicated, there are a lot of moving pieces, then it gets very complicated, and it leaves the avenues open for threat actors to get into the complex applications to the multiple routes they have. And then the one more reason is like branding, right? So branding and customer trust. So once you lose the data, once you lose the customer's trust, once you lose the customer data, you lose the customer trust, and it's very hard to get back. For example, in 2013, the Grasshopper Target lost all of its customer data, and it took a lot of time for them to build the branding and the trust back. And then the last one is emerging cyber threats. So basically, as AI is improving, the developers and the innovators and the makers are using AI to create applications much faster. At the same rate, threat actors are using the same AI to get into the system much faster as well, right? So as fast as we create the application, the threats and the threat actors using the same technology that the innovators creators are using to get into the system at the same time. So these are the several reasons. There are many more, but these are the several reasons which can cost money, time, and the trust. That the reasons are like why we want to save security on our applications. So let's get into what is identity access management, right? So identity access management is provided by many cloud providers. So AWS call it IAM, Google provider, Microsoft calls it Azure AD, and then Google has their own name. But in general, what we are talking about IAM is we are giving an individual or an entity a right access and making sure they access only the things they're supposed to access. So that, as simple as that. So we are just making sure that if you provide an access to the user, they will be using the same resource, not more than that. So that is a simple thing they are doing. So I'm going to explain a few concepts here in general that are used in IAM. So identity. So identity is basically an entity. Here, entity can be an user which are trying to log into a system, or an API which are trying to access another API. API can be identity as well. A resource is trying to talk to another resource, so that can be an identity as well. And a system itself, right? So a system on cloud is trying to talk to another system. So each of these can be identities, and we can give them credentials for those identities, and they act as a party in the handshake mechanism, right? That's identity, which we are trying to authenticate and follow the principles there. And the next concept is authentication. So there are only two things all IAM does at the core, right? Is authentication and authorization. So authentication is nothing but verifying the identity. So if an identity comes and says like, I am this, so we are just making sure that they are them who they are saying, right? If they are saying I'm A, we are just trying to identify if you are A with the information we have, right? So that's what authentication is. Authentication is very, very simple. You're just identifying what they are saying they are. And authorization is where the things get complicated. Is like we are determining when A comes to us and says like, I'm A, I want to access this resource. And then we are determining whether A is allowed to access this resource. If they are allowed to access, we are giving them, we are allowing them to access it. If you are not allowing to access, we are denying them as well. So authorization is kind of two parts here. So verifying whether that particular entity is allowed to access the resource, if not, rejecting them. And then those are the two core principles of IAM: authentication and authorization. And authorization is done through policies. So basically, policy is nothing but uh, a group of permissions that we can assign to an entity. So an entity can do things like X, Y, Z, right? So these are the policies. So we put X, Y, Z in a policy and attach that policy to an identity. So whenever identity comes for an authorization, we see the policies attached to that identity and give the authorization. So in core, authentication, authorization are the functionalities that IAM performs. For performing authorization, it uses the policies attached to the identity. And then, as I mentioned, IAM at the core does the access management and credential management. So credential management is nothing but whenever a identity is registered, it can be user, system, or someone, a credentials are created and properly migrated, properly propagated. And then IAM also performs audit and monitoring. So who is accessing the system, who is not accessing the system, and creates the patterns, and things go from there. So let's dive in deep into the core functionalities, right? Authentication. So as I said, authentication is nothing but we are trying to identify a user who they are saying they are, right? So there are multiple ways of authentication. So each one of these has benefits as well as drawbacks. So the idea is there are more than these. There are more. I listed only 5 of them here, but there are more ways you can get authenticated. These are the popular ones, and even these 5 has benefits and drawbacks. Let's go to one by one. So there is single factor authentication. It's very, very popular that you authenticate into a system using a password or a PIN, right? That's the advantage here is it's very easy to implement, but the drawback here is that once the password or the PIN is compromised, whatever the resources that person has access, the entity has access to, is compromised as well. And then two-factor authentication. Two-factor authentication is one step better than single-factor authentication. We always everybody these days knows about. So once you provide the password, it will ask you for another form of authentication, either sending an SMS, PIN, or asking for a key or a token from a hardware device, something like that. So this will add another layer and secure, better secured than single factor authentication. But the drawback with two-factor is you need to have a kind of a physical device or a digital device with you to have the second layer of the authentication to be done. And then the third one is passwordless authentication. We always see this like biometrics, fingerprint, phones, face scan, things like that. The drawback here, the advantage here is it is very, very secured if you implement correct. But the drawback is you need to have a complicated device which can actually recognize your fingerprint or a face scan in the application and cloud world. When two applications are talking to each other and stuff like that, these becomes meaningless. And then a single sign-on. So basically, this is also very popular. So you have a major, a master account where you log in, for example, Google account. And then once you log in there, you can open Gmail, YouTube, Drive, and Google Drive and whatnot. So that's kind of a single sign-on. The drawback here is once the master account, the credentials are compromised, you have access to all the subsystems under that master account. And then the certificate-based authentication, this is very secured. Basically, if a system or an entity talking to another system, they can present with a trusted CA certificate, and then a system can verify the certificate and let you in. Very, very secured. It's hard to breach. But the problem here is when you have millions of entities that you want to provide access to, this gets very complicated to manage the certificates. Right. So these are the authentication mechanisms. So authentication is nothing but just you are letting a person into the system, but you did not give access yet. So the access part comes through the authorization. So an entity is into the system, but now we need to make sure what resources that entity can access. That's what authorization does. So authorization is mainly based on two things: roles and policies. So roles are nothing but a group of permissions. So basically, we can call like admin is a role. So for example, an entity is given an admin role is nothing but like entity can do anything. So role is nothing but a group of permissions, and basically we can assign role to any entities that we want. And second important thing in authorization is policy. So policy is defining a permission in detail. So for example, there is a resource resource called S3 bucket. So policy is nothing but like explaining the permission on the resource in detail. So we actually a policy document in JSON, like what a entity can do, and attach that policy to a role or an entity. So basically, authorization is based on these two principles, roles and policies. So in short, this is what it looks like in IAM world. There are three parts. There are entities, user, it can be user, group, or a role, which are trying to access a resource based on the policies that entities getting attached to. So basically, we attach policies to the entities, and those entities are allowed to access the resources which are only there in the policies. So we're talking a lot about policies and stuff. So let's just see what a policy looks like, right? So this is one of the sample AWS policy. There are other cloud providers and they have their own stuff, but this is just a sample from AWS. So this is a policy document. So we are just writing a statement here saying this is just an ID, and then the action is allow. So we are allowing. So whichever entity this policy will be attached to, that entity will be able to access S3. These three operations: get, put, and delete on this bucket. So this is exactly that statement is saying, like, if you have this bucket, this policy can be able to access these three operations. And apart from that, they can list all the things inside the bucket as well. So these are the two permissions this policy is enclosed. If you attach this policy to an entity, that entity will be allowed all these operations. So this is the sample policy, and there are multiple tools at IAM disposal that can make policies very complicated and very secure. The complicated the policy is, the secure the resource will be, right? So I picked a couple of those tools today to go in detail. So the first one is attribute-based access control, right? So when you're writing a policy, instead of just writing just read and write operations, you can use the attributes of the resource as well as the entity to define a policy. So it will be very fine-grained, and you can, sky's the limit here. So you can go to any level. So for example, this is ID again, and we are allowing get and put on S3 as an action resource. It's just a bucket name. Then this is where it gets interesting. The condition, right? The condition here is the request tag must be engineering. So basically, the whoever requesting this, so whichever entity is assigning this policy to, they should be, the department of them to be engineering. So engineering department only can access this resource, and the classification on the S3 should be confidential. So only confidential classifications can be accessed, and not just that, the time of the day. So we are adding one more condition saying only during daytime these data will be accessed. So this is just an example. So you can go up to any level here. So you can put time bounds, you can put tag bounds, you can put sizes, and you can do a lot of different things. So this is one of the this is one of the beautiful tool that we have at the disposal, so that you can give access to only the things that you want to give, not one less or not one more. So that's attribute-based control policy. And then next one I want to explain is service control policies. So if you have a huge organization, there can be hundreds of accounts or thousands or millions of accounts under the organization. Service control policy actually creates a boundary for all those accounts. Right. So basically, service control policy will not give access or deny, but what it just does is it creates a boundary, and any account under that organization cannot go beyond this boundary. So for example, if you see here, this statement is allowing anything on S3 and EC2. S3 is S3 buckets, and EC2 is the compute resource that AWS provides. And so this policy is allowing everything on S3 and EC2 and nothing on anything else. So you can see here not action. So not will become deny each other. So right. So basically, we are writing a service control policy on an organization unit so that any account under this policy will not go beyond this boundary. So any account cannot access anything beyond S3 or EC2. So yeah, this is very good tool for not just for security, even for billing as well. And then, so these are the two, like the attribute-based access control policies and service control policies are two good ways. There are many more. I just picked these two to explain at what level, at what granularity we can go writing these policies. So these are some of the best practices that are helpful, right? So whenever we implement a policy or trying to restrict an entity, least privilege is the best way. So we want to give permissions only that they are supposed to have, not one more, right? So that can create a lot of room for threat actors to come in. So least privilege is always the best way, and use some form of multi-factor authentication all the time. And then we always need to monitor and audit IAM activities, because many times we find a lot of different patterns that threat actors use when you actually monitor and audit the logs from the IAM activities. And this is also a very important step, rotating the credentials. So once entity is created and the credentials are given to the entity, that entity will be using those credentials all the time to communicate with the system or login or stuff like that. So regularly we need to rotate the credentials. This will decrease the thread blast radius when something goes wrong. So for example, if two systems are talking together and if you refresh the credentials every 15 minutes or 30 minutes, at max the threat actors can access the system at an average in 7.5 minutes if you give the 15-minute boundary. So the blast radius can be minimized if you rotate the credentials automatically and provide the tools for those systems to access these credentials once they are rotated. So rotating is nothing but creating a new set of credentials for the systems so that they can talk. And then automating the policy management. So we have seen like two simple policies here, but policies writing can be very painful. And there are automation tools that cloud providers provide, and we can use those tools, and we can put the boundaries in the tools too when to create these policies and distribute the policies to the entities. So these are some of the practices that can be really helpful. So now I have a small demo, very simple one. Hope you can still see my screen. So this is why one of my personal cloud account. Go to IAM. I'm going to IAM. So I'm just going to show you how it looks like in the real world, right? So these are some of the policies that are defined that we can use. Most of the times these are really helpful. So for example, if you see the administrative access, right? See here, like everything is included. So allowing star is like you're allowing every action on this account. So I'll be very scared if I want to give this policy to any entity on my account, because for security reasons is one, and then the billing reasons is the next. And then, for example, if you have, let's say, it looks like there is operator access. So this policy is actually going very fine grained, which APIs they can access and which resources and what allowing. So policies can be very big sometimes. So these are kind of simple examples, are already predefined policies. So for the resources that AWS already created. So let's go to users. So what I'm going to do is I'm going to create a user, just demo read only user. So I just want to create access to the console because that's the only way I can show you right now. So I want to create IAM user. So I'm just using some password for demo purposes. I'm going just directly. So I'm going to attach a policy. So this is where, so I'm going to give only S3 read-only policy. So if you look at the S3 read-only policy, we can see here, we can access all the buckets, but we can do only get, list, describe, and get list. So only get operations because we are choosing read-only. We can create our own policies for demo purposes. I'm choosing the default ones we have. So I'm going to use this policy and attach it to the user that I'm created. So these are permissions. I'm just creating the user. So now the user is created. So now let's log out. Let me remember the username is read only. Then I'm going to log out and then sign in here, and then I'm going to use the username, and then I did save my account ID, save somewhere. Sign in. So basically we are signing in as read-only S3 user. So you can see it's already blocked many of the things that it's supposed to put here, because this user who logged in, it can be a system or anything, but for now it's a human, it's me, but it can do only S3 read. So if you go to S3, it can just do read. So you can just read the buckets. But for example, if you are trying to create a bucket, you can just trying to see, like, you can some random text and just create a bucket. It will give the permission is required. So basically this is simple example where I'm giving end user only read-only access to S3 resource, not more than that. So that is it. That's a pretty simple demo, but yeah, that concludes my topic here.
Great. Yeah, thanks for the talk and the demo, Saidaya. Any question for the speaker? Deepak, yes, please go ahead.
Yes, yeah. Thanks for the demo and presentation. So my question is, I see there is a version number in the policies. Is that version number internally generated, or user has to keep track of the version whenever the policy changes? How it works?
So it depends. So most of the times, depending upon on the place, for example, the resource and stuff, the version number is automatically generated. Most of the time it doesn't change, but there is a chance that the cloud provider can change the version number. So changing the version number doesn't, it just means that the format, the semantics of the policy structure is different from the previous version. So usually they will be very communicative if the version number changes. But that's a very good question. It can be changed. And sometimes, if you want a later version of the policy, like let's say there is an attribute which is not in the previous version, but there is a new version, and then when you want to, so things like that can happen, but they will be very communicative, and the tool will be actually very, upfront as well to show like this version does not support the attribute that you are trying to use.
Okay, thank you.
Great. Any other question? Okay. Yeah, I think we can move to the next talk. Thank you so much, Saidaya. Let's give the floor to Kunal. Please, Kunal, you can start sharing your slides and start your presentation.
Can folks see my slides?
Yeah.
Okay, cool. Hello, everyone. My name is Kunal Sekri. I'm a software engineer at Google. Welcome to my technical presentation happening as part of IEEE San Diego chapter seminar series. Today, we'll be talking about machine learning model deployment and serving. Um, cool. So we'll be covering a lot of topics around how to plug your trained model, assuming that you have a trained model, to get predictions, and what are the various options for deployment, how to monitor your machine learning model once it's deployed. So there are a lot of topics to cover. So let's dive into it. As we know, machine learning by itself is not new, right? It dates back to 1950s. In 1950, Alan Turing presented the paper on computing machinery and intelligence, which proposed to consider how machines can think, right? And he proposed a game, imitation game, to determine if machine could exhibit human-like intelligence by fooling a human evaluator in a conversation. This shift was very critical in defining in changing the focus or shifting the focus from thinking to how we can evaluate an intelligent behavior through a practical approach. And then there was a paper written in a game developed by Arthur Samuel, a computer learning program which basically helped to learn how to play the game of checkers better. And what it does is basically assigns the value of each position on the board and try to optimize how the player or the algorithm plays the game. So if it's not new, why it's the machine learning is becoming widespread now, right? That's the question, right? Because with time we have much. The reason is because with time we have much better models which are much more capable of reasoning, learning complex algorithms, and making very accurate predictions. And there are several factors that have converged to fuel this adoption. First is basically we have vastly increased computational power, modern hardware, including GPUs and specialized processors, which allow us to train significantly large and more complex models on massive datasets, something which was impossible in earlier decades. Second, there's a huge availability of data. Data has exploded. Internet, mobile devices generate enormous amount of data, which provides a fuel for powering these machine learning algorithms. These algorithms are now everywhere. They are transformed fields like machine image recognition, language, natural language processing, drug discovery, recommendation systems, and so on. Now, developers and researchers, you can just take a readily available pre-trained model and libraries and deploy them to your application. That's cool, right? So you pre-trained model which works well, like you can take all the best of the models out there and deploy into your application. But what's the problem then? So why are we still having this talk? Cool. So the problem is even though there are a lot of tools and there are a lot of great models out there, applying a machine learning model to production is still very challenging. Based on the survey done by Kitty Nuggets in 2022, only 20% of the models out there are being generated ever reach production. The problem is there's a huge gap once you build a model, and then taking that to the deployment is very challenging. One of the questions which was asked in that survey was, what is the main impediment to the model deployment? And the top two reasons that were called out as part of that came out as a response from the survey was, it was not model performance. It was not like, hey, the models are not performing well. The problem was there was a lot of technical hurdles in implementing and integrating these models into existing operations. You have got the best short model out there, but the problem was how you integrate this model into your existing application. And then there was lack of decision makers' willingness also to approve the changes to an existing operations. There's a little bit lack of trust, how you can incorporate these systems, machine learning models, which generate on prediction, on probability rather than 100% assertions. So what are the technical challenges in integrating these models into existing operations, and how we can convince the decision makers to have trust and confidence into the system? Let's take a look at high level what's the machine learning workflow looks like. It involves like you have a data, you pre-process your data, you work on that data, you do feature engineering, and then you do model training, which involves like selecting the model based on the problem statement. You do feature selection, you do eval the model, and then once you have the pre-trained model, you take that model and then deploy it in production, right? And then which involves a lot of data pipelines, making sure that model is updated and all of those things. And then once the model is out there, you also need to keep on monitoring how you're monitoring your servers. You need to monitor how the model is performing in production. So there are a couple of challenges post model training which we need to consider as we take our model to the production, so that basically we can fully realize the model which performed really well for someone, to make sure the model works best for our use case as well, and also the model that we may have built which really works well in training and test evaluation data that we do, but when you take that model in production, it delivers on its promise. um, so we'll So, as a part of this presentation, we'll be focusing very much on how we can make sure model deployment and serving can be solved, and look at the best options around the model deployment and serving. Before we go on to the model deployment and how we can serve the model recommendations, uh, there are three kind of predictions that three kind of ways how you can leverage the model predictions, right? Think of a model as a system where basically you give an input and you get a prediction out of that model, or a server running that one. So there are three ways. One is the batch, the online, and then the third is on-device one. Let's take a look at the batch one. What is happening in the batch? This is a high-level design flow on what's happening on the batch. Is we have a user who is sending requests to the web server, right? And then web server is making not to the model directly, it's making a call to the database. So what is happening is, behind the scenes, your machine learning model is deployed as a scheduled job or a data pipeline to generate all the predictions that you want offline. So these predictions are then generated, stored into the database, which is what the real your web server or application server will be fetching. So there is no interaction between your web server and the server which was actually used in generating those predictions. There's a lot of benefits, like you can cache it, there is a lot more latency in real time, a lot less latency in real time, and it's mostly typically used when you're scoring large set of data sets and reports. It could be like, let's assume if I'm a bank, I might be doing credit risk scoring for all the customers on a daily basis, right? Um, every day I just generate a credit score for the users and store it in the database, and that's the model is doing. On edge, what is happening is there's a lot of user data coming to the sensors, which are reading the external data and sending it to the application that is running on the device, right? And then there are two patterns here. One pattern could be the machine learning model can be a separate process by itself, uh, or can be bundled with an application. That model is called by the application for generating those predictions. Uh, so all of this happens on the device, right? And the idea to couple couple an inference agent or a machine learning model with an application has its own pros and cons. In a way, how do you want to update your model? Do you want to have your model update cycle along with your application, or has something a separate model update cycles? In this scenario, what is happening is each prediction is happening very much locally on the edge device, right? There are communications that are happening onto the cloud, but those are very async. Let's talk about the third and the final flow. In this flow, in the online prediction flow, what is happening is, in the real time, user makes a call to the web server, and what the web server is now doing is, in a real time, looking up the feature store to extract additional features from the user, and in the real time, on demand, it is calling the machine learning model, which is deployed onto a server, right? and then this server makes a real-time inference call. And in this scenario, once the inference is done, it returns back the results to the web server, and which basically in turn returns the response or post-processes that response and returns it to the user. Caching here can be used, but the caching strategy here is a little different, and it would have a lesser life cycle. If you make call or a TTL of a cache, then you may or can have with a batch processing. So all of this, what is happening for the online predictions, is very instantaneously. It happens like for the user, it makes a call as a normal server call and then gets the responses back. Like this is an example would be like you there's a transaction happening, you want to make sure if this transaction is fraudulent or not. uh, uh, you'll go through this flow. Another example is whenever you land on a page of a Netflix account, or maybe like on Amazon video services, you get those very nuanced recommendations, um, apart from the recommendations which may be generated on the batch one. So the batch ones could be like, hey, the best movies to watch for the day, while the nuanced ones would be just like what you have just recently watched, the last one and the next one recommendations. Cool. If you compare each prediction times, right, we see that the batch predictions generally have a higher latency, but they also have a higher throughput than the online and the edge predictions. But the value of batch is it has support with multiple distributed computing frameworks, so that you can distribute the compute across servers, and it scales really well with a large data set. It is very cost effective to do efficient resource usage, right? But it is very harder to scale when the prediction freshness is a very much of a strong requirement. You want to predict very frequently, and you want the data very prediction to be up to date. Online prediction scales through auto scaling. You can have tens of different servers, you can do load balancing, but the cost will be higher than the batch one, because you always need to have some servers up live there. um, edge is a different ball game. Edge has its own different challenges, specifically around how do you distribute the model updates, and they also heavily rely on the hardware capabilities of the edge device. Uh, based on uh, based on the hardware, you may have to change or choose your model. So end of the day, choosing the right prediction model really boils down what are your product requirements that needs to be solved around what is the latency that you want, how much scalability you want to solve, what is the prediction freshness, do you want really 1 second freshness, 10 minutes freshness, or and the cost of it. Everything, there are 4 vectors, each play a role, deciding on which kind of prediction you want to choose. And based on each kind of the prediction type you may choose, you may have to do post training steps as well. For the focus of this presentation, given there's so many types of prediction types, we'll focus mostly on online prediction type, and we'll try to see that if you're trying to do an online prediction type, we have a well-trained machine learning model, how we can roll out the new machine learning model or the newer version of the machine learning model to production, right? End of the day, rolling out a new model comes up, as you said, it comes its own set of challenges and problem statements to be solved. Because to give an example, you may have written you may be working with Gemini 1.0, you have written your custom prompt, and it was working perfectly, returning responses in the predicted pattern. Everything is working fine. Now all of a sudden Gemini says that, hey, we have Gemini 2.0. And as a team, you have a call. How should you switch from model, which is version 1, to model 2? So all of these rollout strategies will help how you can move your server traffic from version 1 of Gemini to 2 of Gemini, or similarly other models. That model can also be an in-house model, or custom trained model that you may have built for your team and for the custom use case. So the first, the model rollout strategy that we will be talking about is the shadow deployment. what happens in shadow deployment is basically we run a new model alongside an existing one without affecting the traffic. So all the server request is sent to both the model in parallel, to both the models in parallel, but the response of the only live model is used, right? So what happens is you still record the responses of the shadow model and your model along with the correlation ID or a request ID. Uh, and then what you do that is you log all of those responses, and then you sample certain responses for offline analysis. Once those analysis in terms of your performances like precision, recall, and other metric uh, is done, you figure out, okay, which one is the winner, and then you start using the responses of the winner model and start turning down the shadow model. Another strategy is basically you have a live model. The request comes to that live model. You start to roll out small percentage of your traffic to the new model, which we called as a canary deployment. This new model just get like 5% or 10%, depends on the risk tolerance of an application, gets a small certain set of traffic. And what you do is you monitor the similar performance metrics. You also monitor sometimes business related metrics such as conversion rates or click-through rates if it's being used for recommendation, and over a period of time. And if it goes well, what you do is you start gradually increasing the traffic from the live server ML model to the new canary ML model, right? Uh, the value of it is like the new model which is getting used is actually getting tested with the real world traffic, but the con is actually also it could also impact the real world traffic. Um, the server layout, one thing which would be very critical for the cost of running these servers is sometimes it's not cheap, right? Like they're expensive. So the good thing is like you can scale your canary servers as you increase your traffic. While in Shadow, you would have to control your traffic either through sampling and the server footprint through sampling. How much samples you want to use for your Shadow ML model. The third one, which is the most I would say quickest to migrate to the newest to a newer model, is basically you have blue-green deployments where you have a live ML model and then you have a canary, again another model which you want to test. But here you do not do a small person deployment. What you do is in your in the new server, you do all the tests and validations through your test data, and once it's done, you switch over the complete traffic from your live server to the canary server, right? Given it, and one thing which is very critical here is the live server and the canary server to which the whole of the traffic would be switched in a very short period of time. The idea is the server footprint of the, what you call it, blue or the green server would be needs to handle that much of traffic and the scale. So it would be very costly to maintain two server infrastructures with the same scale to handle the production traffic. So what generally happens is, like in blue-green deployments, you need to minimize, or you optimize for minimizing the downtime, and you quickly shift your traffic from green to blue once the tests that are being done uh, are says it's all good, right? One of the another deployment I do want to talk about, which is not a deployment by itself, but it's being used a lot, is A/B deployment. It's if in a way it is very similar to Canary, but the difference is what happens is like you have a live server. What happens is like there are users who sends requests to the web app server, and your traffic is not split on percentage. It could be split on certain user attributes, certain features. To give an example, you could split the traffic based on location, or if you have a new model which works well for a particular scenario, you want to test out this new model based on a particular new concept. based on that, you would try to split your queries onto the challenger server and see how it performs, right? Once the traffic split is done and business conditions work well, right, then and this thing happens for a longer period of time in comparison to canary, because the idea is like you're trying to test out a new concept which can take a week or maybe 2 weeks to be statistically significant, to say that okay, this new concept works well for a longer period, works well for the users that we cater to, uh, or maybe the prime users, uh, and then you shift your traffic to the new challenger server model, right? Uh, so when to choose what kind of models, right? Like there are a couple of model strategies: shadow, canary, blue green, AB. You've got the model out there trained. You're trying to decide which one is a deployment I should choose for my servers to get upgraded, right? Each has their own pro and a con based on the value they provide, like in terms of cost it takes, the risk tolerance, and the time to do the rollouts, right? So a couple of consideration is, when your risk tolerance is very low, prefer canary deployments, and best shadow deployments. But shadow deployments come with their own complications around logging and monitoring, doing some post analysis, and can have bigger delays. Otherwise, the prefer canary deployments when your model complexity is very high, right? uh, and when you need thorough testing and validation with the real traffic, do canary deployments. Whenever you're trying to test a new concept or a new feature vector or something like that, how it performs, leverage A/B deployments with a canary rollout. When the models are very simple, right? Like you have a simple parsing logic which is used internally within the company, an ML model which parses then outputs and gives it spits out something. Then the model logic is very simple, and then you need the minimum downtime. Uh, the blue-green deployments could be the better option. Irrespective of whatever the deployment strategy you choose, always have a rollback strategy. How would you roll back? What are the signals that you will detect to to alert that there is a need for a a rollback uh, of the new model? So these are the higher level guiding lights, if you may call them, how to select what kind of deployment will work based on your use case, right? Uh, One thing I do want to call out is, now we have deployed the model, right? We selected our prediction type. Okay, we want to do online predictions based on our use case. We selected, let's assume for our use case, Canary is working well. We are doing that. Right now, we do not have any new concept to test. How do we monitor the model, right, in production? And it is very essential to make sure that model is still performing well, because the models have learned through the training data, but the real data can change, right? It's important to detect these signals for making sure that model is performing well in production, and it also continues to meet the key stakeholder requirements and the business goals. That's all about building trust in the system and making sure we have good visibility on what's happening in production. Monitoring model in production can have multiple objectives, right? Like what are you monitoring? What are you monitoring for? So the couple of objectives could be, you're monitoring for model performance, you could be monitoring for data drifts, or you could be monitoring for feature attribution, right? This will Let's talk about each of these monitoring objectives and how they help detect different issues that could happen. Monitoring model performance is a fundamental objective. You want to make sure that model, which claim to have 98 or 95% precision and good recall in train, test, and eval, still performs really well in production. So what you would have to do is make sure that model still performs really well, and the performance does not degrade over time, to capture these metrics in production. So you need to establish a baseline during development and continuously monitor these performance against these baseline. And capturing these baselines, capturing these performance in production can be through sampling of certain responses with the ground truth as well, ground truth, right? Along with that, also another thing which is very important given for this is we are serving online is monitoring for latency and throughput so that user experience is not bad. Second thing is like the data keeps on moving, right? Like we trained our model in like 3 months back, 6 months back, but now all of our input features may have shifted, right? So detecting your input feature drift is very important to make sure the model which was trained on input data uh, is still the input data is true or not, right? Let's assume if our model is predicting a housing prices on a square footage in a location, and certainly there is a new location added or a new geographic area that has been added to our application, which has a lot more higher square footage. We can see that, okay, now a lot of queries that we are getting are more higher square footage that could cause our feature drift. It could be good thing, it could be bad thing or not. That will need to decide based on the model performance and other key things that we'll talk about next. Next thing is output prediction data drift. It occurs when the distribution of the model changes over time. So even if the input features seem stable, sometimes your model can start recommending something which you may not have expected. Like let's assume if you're recommending products and it may start recommending scarf a lot more than recommending belts. It may be good, it may not be good. You need to check actually how the model performance is impacted with that or not. But detecting this model drifts would be useful in scenarios where there's an impact to the model prediction. Feature attribution is a general metric where it's a mathematical calculation done where basically you calculate how much a particular feature is important to move the particular output prediction, right? And it also helps like, okay, if there is a certain bias in the model or there are features which are not important, right? Detecting this feature attribution in your output predictions or changes in this feature attribution can be critical. For an example, if an output of, let's to give an example, initially location was not that important, but all of a sudden location becomes an important feature attribute for the prediction. We need to figure out what could be the reasons why that are happening, right? And similarly for the previous purchases may go down, may not be that attribution. So let's take a look at, okay, we talked about a couple of things that could drift. There could be an input feature drift, right? There could be an output feature drift. And there could be things that could change and we need to figure out, okay, what's happening with our model, right? Like, is it, uh, so the general guidelines around on that is if there are no feature drift detected and assuming the team has set up uh, uh, drifts thresholds correctly, uh, and no drifts are happening and model is performing well, that's a happy path, right? Assuming in scenarios we detect the output data drift, but there is no input data drift, right? It could be due to a couple of reasons. First, that input feature threshold is not that sensitive, and because of which the subtle changes are not impacting the model output, right? Other possible could be there's a shift in the user behavior, and the new features are important, which are not captured in the existing model, right? Right. So if the model performance is degrading. In scenarios, if there is a feature drift on the input side, and input feature drift is happening, but the no output drift we see, that means, and the model performance is really well, this means like the model is very robust, and then what we can do is fine tune our threshold for alerting on the input feature drift, so that this does not becomes a noise, right? Uh, there are scenarios when input feature drift is there and output feature drift. That's a clear sign, most likely showing that there's a drift in the concept. In a way, the feature that we deemed uh, essential are no longer essential, and it's time for training the model, and that's called for the retraining the model or upgrading or rolling out a new model. Just best practices to keep in mind: always version your model in production so that it helps with the rollbacks. Have all your ML pipeline code checked in into CI/CD. Leverage the cloud constructs of model registry and artifact registry for persisting the model. Set up auto scaling specifically for online serving so that you can scale as your demand scales. One of the things we do on cloud is warm up your model server before serving, which makes sure that you do not have abrupt high latencies for the initial request. Right. Just have a team checklist for your team whenever you're trying to do a new deployment or incorporating your machine learning into your application. What will be the performance? What is acceptable? What is not? Capture scalability concerns. How would you handle the traffic? What are your latency SLOs? SLOs need to be codified and communicated with the stakeholders. Validate the logging and performance. How would you do the validate and logging, and also do the production performance monitoring? With this, this was the last slide in my presentation, and I'll open for any questions.
Thanks, Kunal. Any question from the audience? Feel free to unmute and ask. So, Kunal, I see that you talk about like, so nowadays there are like these really, really big models running on the cloud, right? Like the LLM models and so can they serve, like how do you ensure that they can produce a prediction within a reasonable time frame? Because the way I understand it, it's like inference can also for those models be like quite time consuming, right?
Yes, yes. So in terms of latency, one is like it depends. Are you hosting the model on your own servers, or are you like leveraging certain open APIs like from OpenAI or Gemini? Most of those models APIs would have a loose SLOs, I would say, call that, like, okay, like around like these milliseconds or so. And then also they also depend upon the configuration in the API that you may set. You may set like, hey, I want these many output tokens and these many to give an, if it's a generative AI, uh, that would govern certain kind of latency consideration. In those, you have lesser control, and you will be at the mercy of the model provider, right? And you will be have to work with the with that. Some things that we do is we do streaming of responses. Basically, there is a latency, but for the user, you try to avoid it by streaming responses. So even if you have not got all of the response, you have a streaming response for few lines of. If it's a generative AI problem, you can show a few lines. Another way to look at it is like if the model is deployed in you're hosting your own model, right? Then you can govern all of those things. There will always be certain baselines which come with the model size and the cost, right? Like you don't want to have beefiest GPU out there and readily available closest to the user location because that comes with the cost, right? But still, those can be solved with general practices, how you can locate your ML models closer to the user, latency requirements with the server footprint. Yeah, so those are a couple of tweaks that you can do to reduce the latency. But as I said, the more it's in-house, the more control you'll have. Or otherwise, you can also apply certain UI tweaks to handle that latency, so that user is still interested while you are doing this prediction.
And also, is there a best practice for like, say if there is suddenly too many queries that you are not, you didn't expect,
Yeah,
Because
yeah,
I think you mentioned there somewhere that scalability is something that you have to keep
yeah,
in mind, but there can always be a case where
yeah,
you became famous and some people are just
yeah,
trying to run. So
yeah.
what to do in that sort of cases? Like what's the
So let's look at whenever there are increased queries, right? Like I look at that, like at my company or what. Always look at from two lenses. Is it a virality or is it an abuse, right? Make
Mhm,
sure that your system has good abuse checks in place, like you throttle user coming from single IP address and all of those things, so that there is not an abuse but an actual real usage, right?
mhm.
Uh,
Yeah.
Assuming that your abuse detector says all good, right? Yeah, it's not an abuse, an actual virality, which is a good, congratulations, you have a good problem to solve, which is where most of the teams have an auto scaling. Auto scaling can happen again at two levels, similar, like basically vertical scaling and horizontal scaling. uh, we do lot of, I think, again, auto scaling, when I mention vertical scaling, is very very quick. What you can do is, let's assume if it's running as a Java server or some a prediction server, you can increase that RAM from, let's assume, 4 to 8, and then GPUs. Again, uh, it depends on the problem, right? Sometimes adding more CPUs and GPUs would help, and sometimes you may have to add more GPUs, and that can take few minutes or an hour, right? So it depends, like the kind of traffic spike it is. uh, Most likely the horizontal scaling would be the solution, and it's a good problem sometimes to have. uh, uh, and then, yeah, setting up the right auto scaling policies would really help.
Okay. Okay. Yeah. Sounds good. So any question from the bridge? If not, I think yeah, we can call it a day. Thank you so much to both Saidaya and Kunal for the nice presentations. The videos will be. Oh, uh, Sam, do you have a question? Okay. Oh, okay, that's fine. Yeah. Uh, so thanks to the speakers for the nice presentation. We'll uh, like we usually upload our talks to our YouTube channel. So we'll do that soon and we'll inform. Okay, thank you.
Thank you.